My name is Philipp Drieger, and I'm very happy to announce the Deep Learning Toolkit for Splunk, covering TensorFlow 2.0, PyTorch, NLP, and Jupyter Lab Notebooks. It's like kind of a big thing for me personally, and I do hope for many of you who can take advantage of this new innovation. I'm here on stage with my good colleague Anthony. Hey. Maybe a quick intro.
We'll do the intro. We have the intro slides in there.
You do the serious parts, right?
So forward-looking statement, we are talking about future product capability and also development time cycles here. So please don't trade securities based on anything we say. Sometimes we lie.
Perfect. The agenda for today, a few words about us, a quick intro into AI, ML, and deep learning, the MLTK Container and how this whole thing fits into the machine learning, deep learning toolkit, and use cases that we want to present and walk you through with a few examples. A quick words about us. Anthony, this is your part.
So Anthony Tejas, staff data scientist at Splunk. I'm responsible for the field relationship. So that's your SE team and your sales teams, and their interaction with product, right? So whenever we're doing new acquisitions or we're developing new machine learning and AI capabilities, it's my job to help your sales teams be successful, help our customers be successful with those technologies, and leverage them as much as they possibly can.
A few words about myself. You hear my bad Bavarian accent. I'm based in Munich, Germany. And I covered a lot of different topics in research over the last years with Splunk, but also before Splunk. I launched another app on Splunk based on this, the DGA app. For those of you who are interested in that, check this out as well. And I'm very happy to get into a bit more serious GPU computing, which I did also before Splunk. My role, similar to Anthony, a staff machine learning architect, ensuring customer success, including, of course, partners as well, to make you kind of successful with those things out there. Then a quick intro into AI, ML, kind of more or less quick.
So just kind of set the paradigm here, right? Like, what is Splunk talking about when Splunk talks about AI and ML, right? And why do we think that AI and ML are valuable to the IT and security analysts? So humans are really good at learning. But we're not very good at processing large amounts of data. We make very vague generalizations around massive amounts of data that we see, maybe petabytes or terabytes of data, but we lose the detail of why we believe, right, a specific transaction is fraud or not fraud or a type of anomalous behavior. So when we talk about other vendors in the marketplace or labels that get thrown around, right, everyone's saying that they're doing AI, and they can claim that, right? AI's most broadest definition is literally just a function that maps a set of features to an output, right? So that could be something as simple as nested if statements, right? It's a piece of software or a function that mimics human behavior. Right? Deep learning and machine learning, on the other hand, are more focused on generating those rules on the fly, using an algorithm that then figures out, based on these rules, or based on the data, what rules can I create to come up with a classification, right? Based on my data, I can identify some of these things as anomalies versus a rules-based approach where I set a threshold and say, if it's this, it must be an anomaly. So what are machine learning and AI, and what are they not, right? It's not a magic wand. There's a lot of misconceptions that you pour a bunch of data, right, into Azure or Amazon or TensorFlow or the machine learning toolkit, right? And out the other side comes some magical business insights, right? The reality is it doesn't work that way. Right. Data scientists spend roughly 80% of their time cleaning and munging data. Who here knows how to write advanced SPL or has taken the advanced SPL class? So you're 80% of the way there to being data scientists, because that's all they do all day is write field extractions, right? Stats command, T-stats command, doing transformation, cleaning and munging that data to get better analytics and metrics out of it. The other part to this is AI and ML are not a total replacement for your SOC or for your NOC capabilities. There's a lot of vendors out there that say we can enhance your SOC and NOC and you can do all this auto ML stuff, right, and auto remediate problems, but you still have to know the core problem you're solving, right? So your SMEs are very important to this overall process, right? Machine learning is a data science process. It's not, just some algebra that you throw data at and then you get a anomaly or a fraud score out of. So you still have to have SMEs that know what fraud looks like or know what a brute force attack or ransomware looks like. And kind of talking about the ransomware example, right? Philipp has an app on Splunk base. This is actually kind of where it comes from, is that DGA app. And we have a hypothesis, right? Almost everything in data science revolves around a hypothesis. And some of the SME knowledge that we have around malware or how ransomware behaves through its command and control mechanisms, right? So there's behaviors that we're trying to exploit using another algorithm, or there's assumptions that we're making about the data to test our hypothesis. Now there are things to, there are things to keep in mind, right? If you don't understand the underlying business problem, it's going to be very difficult to solve that problem with AI or ML, right? I'm more of a generic data scientist. I focus more on security and fraud. So when I get pulled into a customer that wants to talk, right, let's say money laundering or any of those things that I have no experience in, right, it's very difficult for me to just magically create a model that identifies money laundering. Like, they have to explain to me what behavior money laundering looks like in order for me to create the proper model. Now, why we're interested in PyTorch and deep learning, it's about the training time, right? So if you want to operationalize your models, you don't want to be spending lots of time compiling and building those models on CPUs. So PyTorch and TensorFlow give us the capability to leverage GPUs, thereby increasing our time to value. And also our ability to iterate more quickly and redevelop our models or test our hypothesis when they fail. You're up.
Now over to this MLTK container. This was kind of a history in naming it in a certain way. And I want to highlight 3 key benefits that you can get out of this MLTK containers that are consisting in the deep learning toolkit. First, it allows you to integrate seamlessly with the existing Splunk platform that you have, so your Splunk Enterprise, plus your used workflows that you have using the machine learning toolkit, like calling fit for training a model, calling apply for applying a model. So we stick very much to this standard, and still we have the flexibility for, let's say, freedom of code within those containers, including an access to a Jupyter Notebook. This is kind of one experience that I was talking over the last years with many data scientists out there. They all want this Jupyter Notebook. Anyone in the room who wants Jupyter Notebooks? Okay, so half of the room happy, I hope. And last but not least, what Anthony mentioned, if it comes down to training deep neural networks, this can really be compute intensive. You need to figure out millions of weights being backpropagated through the network many times, so it's a very time-consuming or computational expensive process. That's why GPUs can accelerate this, and frameworks like TensorFlow or PyTorch natively support that kind of acceleration, which is good to use for certain use cases. Now, on a very high-level architecture, how this looks like, if you read the slide from left to right, you see all the data sources flowing into the Splunk platform, and then you do your search. Still, search is the central component in the whole architecture here that allows you now to talk literally or communicate to this so-called MLTK containers, and those can be multiple ones. You can have a development container that your data scientist is working with and developing code, accessing Jupyter Notebooks, doing stuff, experimentation, and you have kind of, let's say, production containers that you want to just apply constantly with your scheduled search or with other mechanisms that you want to have for model serving, model execution. Now, everything that is in this blue box in the current version is served on a Docker environment. So a Docker container that consists all of these libraries and pre-built container images. And still the closing loop is then that if you execute a search that calls this container and gets results back, of course you can interface with all the possibilities that you know from the Splunk world, visualizing stuff on a dashboard, building up alerts, so operationalizing the whole thing as you used to work with Splunk. So this is the seamless and tight integration. Now, a few words around GPU-accelerated training. Many deep neural network algorithms are really kind of compute intense. That's why also with the help of Docker, and in this case specifically the NVIDIA Docker runtime allows you to also access the underlying hardware. Feel free to study this topic a bit if you get started. It's not super easy. It's a complex topic in itself. Parallel computing, distributed computing. We know there are many, let's say, caveats that you need to take care about, so handle with care. That's what you get into. From a workflow perspective, this is like a little flow chart that I was trying to sketch out that walks you through 7 steps here. First, you do a fit MLTK container. There is a mode built in that tells you I just want to stage over a bit of data into the development container, just for doing experimentation. Likely this is a sample set of data. It's not the full set of data that you want to feed in there. This is what you do in the first step to use the container here, the development container. Then in the next step, you actually run step 3. You do the fit MLTK container, defining your algo equals your algorithmic definition that consists to the same naming convention that you use in the Jupyter Notebooks. So this is kind of your name, and please stick with your name. Please use underscores to not break the parameterization if you call those things. With that, you then feed the models. You feed data out of your Splunk search into the container. It can be still a development container. It can also be a production container. The app does hopefully intelligent routing of if you have an up and running container and you have the name given with the into keyword to save the model, then it knows which container to talk to. So this allows you to orchestrate, manage what you are doing there. Afterwards, let's say you have trained such a container, may it be a TensorFlow or PyTorch based one. You could run multiple of them in many choices. If some of your data scientists want to use PyTorch, they should use PyTorch. The other ones use TensorFlow, so feel free. And after that, you can serve the model by just calling apply my model. This is again routing to the right container and getting the results back seamlessly. Afterwards, you can still define even your custom model summary to maybe inform someone what was the last accuracy rates that you achieved, how does the network structure look like, and so on. So all different handy things. After that, you can still do a partial fit or still a retraining of those things on the fly. From a quick syntax overview, and I will jump over these slides a bit more quickly, you have them all for your reference later on. You just do the fit. Algorithm is in this case kind of the old notation from the MLTK. In the DLTK execution, it would be MLTK container. This is kind of the algo. Think of a proxy that allows you to go into that container, and then you just do algo equals your algorithm or notebook definition that you have there. You can have arbitrary key value based parameters like the amount of epochs, or if you have special parameters that help you to control how your model works. This is all piped over as metadata into the container as well. So this should give a data scientist or machine learning engineer a lot of flexibility to seamlessly still have on the Splunk side and in the container side kind of the close connection. And then as you used to have this, you save the models into a model. So the model is also saved as a lookup on the MLTK side. So this is kind of consistent also with that. And that's more or less how it works. A few examples here. Mode is one special thing, epochs, but feel free to take this as a documentation more. Now, to save a bit more time and go actually in a demo, for of course having not crashing something, and feel free to try this out on your own. A few key slides that I was screenshotting out here. You see this is a content overview of the whole app. The app ships with an overview, how the architecture can look like, what are different deployment modes, what are, let's say, guidelines and explanations and walkthroughs, how this rapid development of models look like, how you interface with the Jupyter Notebooks and the pre-built, predefined notebooks that are shipping with this app as well as infos around GPU computing and distributed computing, what you maybe should consider or link to the according pages on the framework sites. The center green section allows you over the UI to set up the whole thing. So you don't really need to go down to the command line. You just need to define how actually the setup looks like, connecting to your Docker environment, and then the app is handling the communication over there. Below there, the page is still going on. A lot of examples shipped with this app, so feel free to take those examples. They are maybe not the best examples built on planet Earth, but data scientists knows how to improve it or even adapt it to their use cases, so feel free to explore them as well. This would be how you do the setup. The app checks for dependencies like the machine learning toolkit. This is a must-have to run this app because it uses all its APIs and the fit commands, stuff like that. And then you literally do 2 entries, and this is still an old slide. The new has even a third information that you can put in. So if you run on the same machine, your Docker environment, you simply connect over the Unix SOC. Otherwise, you can also communicate over TCP to the Docker environment. This is just for calling the Docker API that then launches the containers for you. And this is, again, just triggered all over the UI and in the app. You define also how the containers communicate, and you also have as a third kind of input how you externally maybe have access to this instance. For safety, security reasons was kind of introduced here. Please also take care to secure your environment in the right way, so the app is not making you secure on that side. Yeah. This is kind of the overview how the container management can look like. So you have all different links. You can choose from a drop-down which pre-built Docker image you want to run. The image is getting spun up for you. It is getting listed here in the overview page, and you have buttons that let you access the Jupyter Lab interface and even TensorBoard if you want to do a TensorBoard investigation, how your training was doing over time. And from that perspective, you can easily, spin up your containers, jump into Jupyter Lab notebooks, do your stuff, and get things back into Splunk. For example, to build out an example dashboard, simple one, just for binary neural network classifier to say I take a data set. I'm also using many of the example data sets from the MLTK, so you can run all these examples on your own and do, in this case, maybe a binary classification. From that perspective, this is, as I said before, the reusing the results, everything that is happening inside of Splunk, in Splunk dashboards, in Splunk alerts if you want to build them up. And if you jump over to the TensorBoard and see actually how the execution is going on, how the training evolves over all the epochs, this is what you can easily pick up. The example before was TensorFlow. Now this is a similar example, a multi-class, simple logistic regression implementation example for PyTorch. So feel free to pick this up, look at it, and if you jump into the notebook, this is what you find. You find it pre-populated with a lot of existing Jupyter notebooks. A few words about the notebooks. They give you predefined cells where you feed in your code to define your model. When you hit save, the model is more or less exported into a Python module under the hood, which is used for serving the whole thing. So you have kind of a separation between developing things in a notebook and still having your production code into the Python module that is called. Feel free to take those existing examples, more or less copy-paste from them, Of course, if you know what you do, you can screw it all up and do things on your own. That's fine. But I would recommend stick to the things that are there for ease of use. Now, another example to bring this back, for example, using an LSTM model, a long short-term memory for forecasting. Maybe if that's your use case, maybe this is one of the starting points that you can reach out and do. So as from the forecasting use cases, you can see the green line that's going into future is more or less the forecast that comes out of this LSTM trained model on the historic data. There's another approach like using a CNN even. Usually CNNs are used in image recognition, image use cases, but potentially you can also do forecasts with it. So feel free to explore this example as well. And now, very interestingly, as a maybe last part at this section, NLP, a few words around NLP. It's natural language processing, so you have natural written texts, like think of your emails, the reviews that maybe your customers post on a forum or something. You want to extract information that is pre-trained by pre-trained language models, like what are persons, what are organizations, where are dates, places. So especially in the intelligence area, this is kind of very good for information retrieval. And of course, in this case, you can easily pipe in your text for testing over there. And in this case, Spacy as a library for NLP is used here to do entity extraction and recognition. So pretty advanced, pretty interesting. Feel free to explore a bit more. There's also GenSim, NLTK, more or less all the Python-based state-of-the-art NLP libraries out there that are packaged up into this container. It's the NLP container. From that, I hope this is good for you to have a quick overview. Feel free to, of course, come back to the app. The app is much more containing all the details, and handing over to Anthony for a few use cases.
Yep. So we'll talk a little bit more about use cases and what you can do with this, right? So if you've ever seen these slides from the MLTK or any other MLT presentation, we more or less stole them, and then we repurposed them with the deep learning variants, right? So these are the customers when we interact with a customer, they want to solve one of these three problems, right? They want to do anomaly detection, right? So I have some entity or some device or person whose current behavior deviates from their historical baseline. I have predictive analytics or forecasting, right? I want to forecast the future. Maybe I'm trying to forecast server time, cloud usage, right? Any kind of KPI. And then lastly, we have clustering, and this is kind of where AutoEncoder fits into that, is I want to learn everything in my data. It's more of an exploratory data analysis approach. I learn everything in my data, and I do this thing called reconstruction. And when I reconstruct those observations, if I have what's called a reconstruction error, then that host or that observation has deviated from a baseline that exists in my data. So what does an anomalous access pattern look like? Right, so if we want to identify entities with deviations from their past, right, so users or KPIs that have changed over time, LSTM is actually really good at doing anomaly detection and forecasting. And so what we do is we more or less learn the patterns in the data, right, because an LSTM is a long-term, short-term memory, so it has these memory cells that retain information about each entity and the KPI that was trending through time, and we forecast for the next minute. And then we compare real, right, to our forecast, and if it's within our prediction, right, one standard deviation, it's okay. If it's outside of our prediction, then it's an anomaly. Fairly simple. Philipp will cover more on an actual customer that implemented this.
Yeah, quite, let's say, luckily, I was able to collaborate with a customer in Germany, representing them here as well. Not able to join our conference, but still were able to publicly reference a use case in more IoT space, predictive maintenance at Volkswagen in Germany. They had research going on to find actually what is the proper operation of my equipment. And in this case, they want to detect the wear-off that is happening in industrial equipment, in their production lines, in their assembly lines. That's why they were kind of elaborating really very research intensively on finding, in this case, a recurrent neural network that fits their use case really good. And in this case, they apply this network to the stream of data that comes in to get, again, a type of an anomaly score or a deviation, very similar to what Anthony explained before, to say when is something going not so normal anymore. This is, again, something that you can use as an information to say, okay, now potentially this equipment wears off, I need to replace it, I see strange patterns, and I can act before it actually, breaks apart or does some damage or does something. In this case, it was very interesting to see how quick it also went. We spent 1.5 days together, literally working out, putting their code into this deep learning toolkit framework, more or less like a doctor dissecting a bit bits and pieces. That's why I'm wearing always these codes here, to say, okay, let's put this code here, let's put this code there, and they operationalized the whole thing in really 1.5 days. So I hope this gives you an impression also on the speed of or the rapidness of getting things into. One nice example out of the IoT space, next to another interesting space for you, Anthony.
Yep. So autoencoders have been known for a while to be actually fairly useful in fraud detection. So you can think of an autoencoder as kind of what you see here, right? I have an input variable that could be the transaction amount or the merchant ID, right? And for each feature that's input, I have a one-to-one match of an output feature, right? And I have these neurons here in the middle that are learning the relationships between each of my input features and then trying to make sure that the output feature more or less matches that, right? Like, what's the relationship in all of my data? So when I learn all these patterns, right? Excuse me. When I learn all these patterns, I get this thing that I talked about earlier called reconstruction error, right? So if I take a bunch of transactions, so let's say ATM transactions or credit card transactions for my users, I can learn all of the behaviors that exist within that data, right? So for each transaction, in this case, we're going to take non-fraud transactions. We're going to learn everything about the non-fraud transactions. And so when we reconstruct that transaction, we'll have this thing called a reconstruction error. And it should be fairly low, typically. If I've trained my neural net enough, it should be able to take any of the other features, right, and be able to know what the other outputs are. So what happens is I've trained this neural net on what a normal transaction looks like. I then apply that neural net to potentially fraudulent transactions or other transactions I haven't trained on before. And when I get this large reconstruction error, right, which is K, right, I have some K threshold, those are fraud candidates, right? Because the reconstruction error is basically telling me that these transactions don't look the same as the normal transactions. There's something off about them. I'm not able to accurately predict an output, right? And when I do the comparison, right, basically x minus x hat, I end up with that reconstruction error. And so what you can do is take it a step further and then you optimize for K to minimize your false positives. And then you implement that in real time on new transactions coming in to give you information related to, is this transaction a normal type of transaction, or is it something that looks more like a potential fraud candidate? This is you.
I take it. Kind of to wrap up and give you a few key takeaways about this session. First, please use this app. Please give feedback. Extend the machine learning toolkit with this app. It's not a replacement for the machine learning toolkit. This is also very important for you to know. It's for special cases. For most cases out there, go with the toolkit because it's much easier. You don't need to write code. You just do a fit density function, have an anomaly detector. So it's really from the target persona as well, a data scientist, a machine learning engineer, more a developer persona who knows what to do with this type of code and Jupyter interfaces. Secondly, go forward, integrate your custom advanced deep learning or NLP or whatever related models into Splunk using this little, let's say, proxy or this little vehicle that is hopefully helping you to speed up on doing these things. I had interesting experiences with many very smart customers out there who built, let's say, very interesting constructs of developing this type of functionality. So hopefully their life is getting a bit better. That's my hope. So let me know if this is happening. And last but not least, if you have the need for really have computational heavy workloads, this gives you kind of the first technical step into GPU computing outside from the, let's say, Splunk perspective to go into that world, if you need to. Many problems still out there are still, let's say, not necessarily a deep neural network problem or a GPU to be computed problem. So still, if you think about the terabytes or petabytes of data that you have as ingest, very likely you extract certain features first, and then you do modeling on top of that. Of course, there might be situations where you want to run things on raw data, but still, in most cases, from typical data science workflow, you do feature extraction, feature engineering that is happening still, and take all the power of the Splunk platform for doing this in classical SPL. As we introduced before, do your SPL, data prep, do your fit MLTK container. You could even interchange and say, I do a standard scaler from the machine learning toolkit first, and then normalize data and get this over to the container. So you can really build very complex data pipelines with the whole concept here. Now, last but not least, if you have not yet, let's say, even downloaded it maybe today, how do you get access to this new toolkit? Good news is it's free of charge. It's on Splunk base. It's an app that is out there. Yay! Release party. We made it. But nevertheless, as I said, download it from this link or just look on the Splunk base. Secondly, also there is a GitHub repository public there for you, for those who want to build your own custom containers. Still, the containers that are pre-built, maybe you're very security aware, you want to build stuff on your own, you want to know all the sources, feel free to build your own container. Read how you get the container into this framework, so this even gives you the flexibility to build your own containerized whatever. This makes you also a bit, let's say, future-proof in terms of whatever next nice framework that comes up on the planet and your favorite data scientist wants to try it out and work with it, feel free to take it into this container and use the whole framework to work with this. Last but not least, also to say, of course, professional services from Splunk are here to help you, either from a, let's say, data science or machine learning workshop type of style, but also for implementing this specific solution in your environment and also hardening it and making it as secure as possible in your existing environment. This is, of course, hard to foresee from an app development perspective that every app already matches all requirements. That's why please reach out to us and let us know where we can help you. Any other closing words from your side, Anthony?
No, just Q&A. We have, I think, 12 minutes for Q&A. So
yeah, plenty of time left. So we are speeding a bit through. We need to count. I just be pragmatic from right to left, right? So to
GitHub doc placeholder.
What again? Sorry.
There's a GitHub doc placeholder. What is the GitHub?
Oh. Yeah.
It's a placeholder. Look into the app. The link in the Splunk base app guides you to the GitHub.
Thank you.
Sorry for that. This was one of the last minute changes. Yeah.
Will it be available for cloud?
I'm not yet. I need to have a few conversations with the Splunk Cloud Ops team first to make sure. This is exactly one of the points to discuss. So to have, of course, if you want to have a GPU in the cloud, in a Splunk cloud managed hosted environment, this is something that needs to be sorted out still. So I'm in conversation with the guys, but as of today, it's, let's say, on-prem or your own cloud. Yeah.
Great presentation, thanks, excited about it. Question, since you're doing all your processing in this container outside of your environment, when you're re-ingesting, is that going against your license?
No.
No, it's all search time, right? So think about what the toolkit does, right? It displays the result in line in the search pipeline. This is doing the exact same thing.
Yep. So it's not really re-ingesting into the index. I mean, potentially you could send out events from the container to a hack. There's also still the option to do the logging of the whole container and collect it and monitor the Docker behavior. I did not do this yet, but it would be easy to just get all the logs that come out of the containers and monitor what this environment is doing for you, maybe in the future. And I come back to you. We go over here, but yep.
So first of all, thank you so much for making that happen. I've been doing a lot of work where I've been able to create lookups to create a data frame externally in a Docker container. So the fact that you guys have made this important is super cool. I did have one question in terms of how it works. Like, let's say that you want to export essentially the pandas data frame, a data set that you want to work with and iterate on, or even a grid search across different hyperparameters. Is there integration for that, or something we'd have to kind of build in? Because you said there was parameter features you can kind of add in.
So there are, let's say, two aspects to think around it. I would do the grid search in the code directly, to say you pipe your data frame over to the container, use scikit-learn pre-built grid search things or your own or other frameworks choices, and run the grid search in the container. This would be my preferred way to do it. The other way, we have seen in other presentation in Splunk, you have the map command. The map command gives you a certain type of iteration capability to actually spawn out a lot of different searches. How good this really fits together with getting your container called hundreds and hundreds and thousands of times, it's maybe better to do the offload or do the work in the container. My current estimation. I did not try it out yet, so let me know. Okay, great. You're welcome. Any other questions over here?
Over here.
Or- Yeah, please.
Yes, we touched on the question, but you're talking about deep learning, but if I have some models that I'm currently extending in the MLTK, like custom models, but I really don't want to use my cycle on my search head, is this a way I can proxy my data frame over to my custom model in a container, in the work, and then bring it back? Or it has to be deep learning model?
Not necessarily. It's called Deep Learning Toolkit because it allows you to, let's say, go into that deep learning type of modeling space, but you could even do a 1+1 in the container. So it doesn't need to be a super fancy model. You can also, let's say, use other, let's say, existing functions that you have in the container from scikit-learn or from stats model or any other Python libraries that are packaged in your container. So I would say, yes, you can do this, but it's not really, let's say, restricted only to deep learning. It's
Potentially. I think it depends on your architecture. I mean, the way that we design this is the Docker container in most deployments would sit on the search head, right? Because you want to minimize latency between the search head's API and the Docker container API. So in order to do that, we just cheat and use the loopback interface, right? So
if I want to save my search heads, you're saying that's not recommended to scale this container?
So what you could do, and this is where we're talking about like that external hosted Docker environment, right? Like if you have a model that's already in prod, you could have your search head send incremental amounts of data for scoring, right? To come back with a classification or an anomaly score. And then that wouldn't be running, right? You wouldn't have CPU contention on the search head. It would be running over on, some Kubernetes cluster or something else.
So you mentioned in your toolkit leveraging GPU for the computing, etc. Is it, are you partnering with some vendor like NVIDIA or?
So it's leveraging the NVIDIA Docker. Yep, and that allows Docker to hook in directly to the NVIDIA GPU cards. Now, the one thing that is documented in the app, and we didn't cover it here, it's only specific versions of NVIDIA cards work, and that's a TensorFlow dependency, right, for for parallel processing.
So NVIDIA has a Docker
Yeah, they have their own version of Docker that has kernels and drivers that allow that version of Docker to basically leverage the hardware.
So are you partnering with NVIDIA for these?
No, we've just, they have an official image that's open source, so that's what we leveraged.
And even this is kind of an update to that one. It's using the second version of Docker that allows you to attach this runtime parameter when you start the container, and then you have the, let's say, driver NVIDIA, and then it talks over the kind of existing things with the NVIDIA hardware. Currently, as of today, this was the, let's say, most, at least to my knowledge, widespread, let's say, combination of using containerized GPU computing. That's why we are kind of currently sticking to that choice, but let's see what the future brings up. Can you speak up a bit, please?
Bioinformatics for the FDA, we have online instances. We use we have different de novo algorithms. So anyway, that's one instance we have up there. I can use Amazon's GPU instances in theory.
Yeah, so that's what we're building. I mean, so that's what we're testing on, right? I have an Amazon P3 instance specifically, and that's how we're testing the GPU capabilities.
And then
right.
when you're firing off, because I'm used to the SageMaker,
Mm-hmm.
and it's different interfaces. For this though, which is really interesting, when you fire off obviously your Jupyter Notebook instance, that's outside, when you see its output.
So the Jupyter Notebook is more or less providing a window into the container, right? So you can modify that Python file and the APIs or anything that you're building, right? So if you're building an LSTM and you want to change some hyperparameters, that's the best way to do it, right? Because you want to hot reload that file. You don't want to necessarily have that sitting on the OS. Yep. Yep, and you can, if your container breaks, I mean, the beauty of it is you just kill it and restart it and build a new one, right?
That's a good question, Bojan. Well, we had the forward-looking statement, right? So
yeah.
My assumption would be, let's see what this year, with this app and all, hopefully your feedback that is coming back to help us, sort out what would be the most prioritized things. We heard Kubernetes from the side over there. Potentially, this is one of the next reasonable and logical things to expand on that way, and let's see.
What's the best way to provide you guys with feedback from using it? I plan on getting into it immediately.
So it's on Splunk base. So Splunk Answers is an easy one, and then the GitHub repository that we link to, right? That's another one. If you're building your own custom images, right? Like we also kind of want to know, like, if our base image isn't that good or we're missing libraries that people think need to be included in that base image, then we're open to updating that. I mean, the way that the image is now, it's a little bit of the wild, wild west. Like, I was like, hey, Philipp, can you add these other scoring libraries? And he just added them. But there's other, there's other libraries out there that customers are going to want to leverage for various types of problems. We're just scratching the surface, really, of like the different types of use cases customers can go forward with now.
This toolkit has any dependency of the personalized Splunk? You can use it on.
At least 7.3 is what we've tested on. 7.2, I think, will probably be okay.
8.0 is released.
8.0 is released, but we don't always get the pre-release bits to test, so.
It's not officially GA, like you said, it's announced.
What is?
8.0.
I'd have to check the website. I know that the new toolkit, the new machine learning toolkit that is out, but it depends on 8.0. So.
But you don't have a dependency on 8.0.
No, our only dependency is on the toolkit. Yeah, so the most 4.5? I think at least 4.5 of the toolkit, because the APIs haven't changed since then.
But also feedback-wise, shoot us emails, let us know. Yeah.
Okay.
Anything else? 1 more minute left. Excited so far? Yes. Everyone happy? Okay. Great. I handed out stickers in the beginning. Maybe some people who came late, if they want to still catch a little sticker for their notebook or laptop, feel free to pick one.
All right. Thank you.
Thank you.